through lesson 16, which is on adding and subtracting radical expressions. Okay, so first we're going to start with a little bit of pre-algebra algebra 1 review just so we can refresh our memory. So remember, when we're thinking about combining like terms, what we do is we're going to add or subtract the coefficients, and we do not change the variables. Okay, we're going to apply this same idea to adding and subtracting radical expressions, and keeping in mind, if we don't have like terms, then that means we can't combine them. Alright, so let's look at what we already know. So say we have 5x plus 14x. Well, before we add these, we need to say, are these like terms? So they are, because they have the same variable x with the same exponent, which is an implied 1. So then in that case, what we're going to do is we're going to add the coefficients, which would be 5 and 14, to get 19. And then the variable and the exponent stay the same. So just stay 19x. So the same thing would be true here. So 3x minus 21x, we would subtract the coefficients, so 3 minus 21 would give us 18. And then the variable and the exponent is the same here. It's x, and it's implied to be the first, so we just get negative 18x. Okay? Keep in mind that if we had, like, say, for instance, 3x plus 2y from pre-algebra, and you were asked to combine like terms there, you couldn't do anything because this has an x variable and this has a y variable. So you just circle that and just say, well, I can't simplify. That's my answer. Okay? So now let's look at it from an algebra 2 perspective. So I have 5 square root of 2 plus 14 square root of 2. So the radicals are already simplified. I can't break down square root of 2 anymore. And they are the same, right? They're both square root of 2. So then I'm going to keep that as square root of 2, and I'm going to add the like term coefficients, which is 5 plus 14. So 5 plus 14 is 19. And then the square root of 2, just like when it was an x, it's going to stay the same. So that's my answer, 19 square root of 2. So over here, same thing, 3 square root of 7 minus 21 square root of 7. So 3 minus 21 is negative 18, and then the square root of 7 stays the same. Okay? So just to show 2 more examples there, say I have 5 square root of 7 minus 3 square root of 7. Again, the square root of 7 is the same. I can't simplify that any further, so it's going to stay a square root of 7. And I'm going to subtract the coefficient. 5 minus 3 is 2, so 2 square root of 7. And then if we look here, I see 5 square root of 3 plus 9 square root of 11. So these radicands are not the same. And because 3 is a prime number and so is 11, I can't break those down with a perfect square. So really, question 6 here is kind of analogous to this extra problem I threw here, 3x plus 2y. I can't do anything with it. So since these are different radicands and I can't break them down, this would just be my simplified answer. I couldn't do anything else with it. Okay, so now let's look at it when they are different radicands, but we can do something. So here you see 5 square root of 2 plus 4 square root of 18. Well, 5 square root of 2 can't break down any further because square root of 2 is the simplest square root we could have. No perfect squares will divide into 2. So that's just going to stay as 5 square root of 2 the entire time. So then we see the 4 square root of 18. We need to simplify that. So I need a perfect square to break down 18, which I should do with 9 times 2. Well, now the square root of 9 is 3, so that's going to multiply with the 4 coefficient. 4 times 3 is going to give me 12, and the square root of 2 stays inside. So now we've gotten 12 square root of 2 from the 4 square root of 18. When we broke it down with a 9 and 2, again, square root of 9 becomes 3. 3 times 4 is 12. So now notice the radicands are the same. They're both a 2. So now I can add the coefficients. 5 plus 12 is 17, and the radical 2 stays the same. All right, let's show it again here. So 6 square root of 5. Well, square root of 5, 5 there is a prime number, so I'm not going to be able to break down 6 square root of 5, so I'm just going to keep bringing this down as I have to break down my 7 square root of 45. So my first step here is to find a perfect square that can break down 45, which should be 9 times 5. So the square root of 9 is going to give me 3, so I get 7 times 3 square root of 5. Well, 7 times 3 is 21, so now I get 21 square root of 5. And then lastly, when I get here, I need to say, are these radicands the same? They are, right? So I get square root of 5. I do 6 plus 21. Well, 6 plus 21 is 27. So I get 27 square roots of 5. All right, and then last but not least, we're just going to do the same thing, but integrating a variable in with it. Okay, so here we see square root of 48x to the third plus square root of 75x to the third. So square root of 48x to the third, well, I need to break down the 48 part, which I should break down with 16 times 3, and the square root of 16 is 4, so that goes to the outside, and the 3 stays on the inside. Then I have x to the third. Well, I'm going to break that down. Again, how many sets of 2 can I make out of 3? Well, I can make 1 set of 2, so I get an x outside with 1 left over, x inside. So I get 4x square root of 3x. when I simplify just the first term. Now I'm going to simplify the 75x to the third. So I break down the 75 with 25 times 3. Okay, now when I do that, the square root of 25 is 5, so that goes to the outside, the 3 stays inside. And again, how many times does 2 go into 3? Well, it goes in once with one remainder. So I get 5x on the outside with the radical of 3x on the inside. Well, now, are the radicands the same? Yes, so I keep that the same, and I add the coefficients, 4x plus 5x. 4x plus 5x is 9x, so I get 9x square root of 3x. Let's show one more example for that. So here I see square root of 98x to the fifth. So I'm going to do 98, breaking that down with 49 times 2. And then the square root of 49 is 7. And the 2 stays on the inside. Now for the variable, I see x to the fifth. So it's how many times 2 can go into 5? Well, 2 goes into 5 2 times, so I take out x squared with 1 remaining, so that x stays on the inside. Well, now I need to break down with the 50x to the third. So I'm going to break down my 50 with 25 times 2. Square root of 25 is 5. So that 5 is going to come out and multiply with the 2 that's already out here. So I do 5 times 2 is 10. And then the x is here. But now I see x to the third. Well, remember when I have x to the third, it's how many sets of 2 can I make? Well, 2 goes into 3 one time. So that's going to multiply with the x that's already out here. Well, x times x, when we're asked to multiply with exponents, we add them, so I get x squared. Well, what's left on the inside? Well, the 2 is, and then our remaining x, because remember out of the 3, 2, we had one set of 2 with 1 remaining. And now we notice our radicands are the same, so that's the square root of 2x. And then we look for our coefficients. Well, 7x squared plus 10x squared are like terms. We can add those to get 17x squared square root of 2x, which would be our final answer. All right, this is for lesson 16. Hope these help.